Hello everybody. Today and this week what we're going to look at exclusively is limiting reagents. And the idea behind limiting reagents is when you react two things or more than two things, this could be 3 or 4 or 5 reactants, whatever the case is, one of those reactants is going to run out before the other unless you measure out exactly the correct number of molecules of each of these, or in theory, the exact number of moles. So if I wanted to create a mole of glucose and 6 moles of oxygen, I would need exactly 6 moles of carbon dioxide and exactly 6 moles of water. But in real life, it's very difficult to get exactly those amounts. One of those two is going to run out first. Often in a chemistry lab, we spend a lot of time trying to calculate as close as possible that we can to equalizing those so that there's nothing left over, which could then contaminate our sample. But in reality, scales and measuring devices only go to so many decimal places and so many significant figures. So we're left in the real world with having extra contaminants left over, or basically a limiting reagent and an excess reagent, one that's left over and one that's gone first. The thing with limiting reagents and doing stoichiometric calculations is that we have to use the quantity of limiting reagent when we do calculations. So in this question, what we're going to do is we're going to determine the limiting reagent based on the question that it's giving us, and we're going to do this in a couple steps here. And when we're done with that, then we're going to determine how many grams of glucose is produced by that specific reaction. So in the question here, I'll just move this over a little bit. In the question here, it says we have 6.26 grams of carbon dioxide and 15.9 grams of water. So the first thing I'm going to do is going to write those right underneath my values here. There we go. And the second thing I'm going to do before I even get started is I'm going to write the molar masses of all 4 of these reactants down. You guys probably have noticed by now molar mass is a very important part of unit elimination questions. So I'm just going to pop those on the page like magic, and there they are. So when we calculate the limiting reagent, at this point what we want to do is basically break the question down into calculating how many actual moles of carbon dioxide are present in that 6.26 grams, and how many moles of carbon dioxide are needed to fully react with the 15.9 grams up here. Now, because I did all this while talking and also afterwards noticed that my camera was off, I'm just going to cover things up and point to them and talk about them to explain how things go so I don't have to redo it. To calculate the actual moles of carbon dioxide, what we're going to do is we're going to start with the grams of carbon dioxide that are given to us. So we have 6.26 grams of carbon dioxide. And if we multiply that by 1 over the molar mass there, or 1 mole per 44.0096 grams, then you will get the actual number of moles. Grams will cancel out with grams, and you got moles of carbon dioxide. So that's just 6.26 divided by 44.0096. That'll give us 0.142 moles of carbon dioxide actual. So that's the actual amount of carbon dioxide that is present in this reaction. Now what we're going to do is we're going to compare that to the amount of carbon dioxide needed to actually react the full 15.9 grams of water. And then we'll be able to compare those two numbers and determine which of the two reactants there's not enough of, or which one is the limiting reagent. So let's go down here and calculate the moles of carbon dioxide needed. Now in this case, we're going to start with the grams of water because I want to compare how much I have to how much I need. So let's start with the grams of water to be able to get how much I need of carbon dioxide. Now we're going to multiply that by 1 over the molar mass of water, right? That 18.0153, so that we can get moles of water. But again, we want moles of carbon dioxide, not moles of water. This is a regular unit elimination question, so we're just doing the same steps as usual. So we are going to have to multiply moles of water by some ratio that has moles of water in it. And at this point, then you can use the stoichiometric ratio, or the 6 moles of carbon dioxide over 6 moles of water, provided by the coefficients in the equation. 6 moles of carbon dioxide right there. 6 moles of water right there. Cancel those guys out. You're left with moles of carbon dioxide. With that, now we can take our 15.9 divided by the 18.0153, multiply by 6 and divide by 6. Some of you guys are probably thinking, why would we do that? That doesn't do anything. And that's true. You can actually skip these because if you multiply a number by 6 and divide a number by 6, nothing happens because that's like multiplying by 1. And that gives us a final answer of 0.883 moles of carbon dioxide needed. So think about it this way. To react all the water, I need 0.883 moles of carbon dioxide. But I have 0.142 moles of carbon dioxide. So logically, we could say that this is going to be our limiting reagent. Carbon dioxide, there's not enough of to fully react the water. Therefore, carbon dioxide is my limiting reagent in this question. All right. For the end of the question, what we're going to do is calculate how many grams of glucose is actually produced in this reaction. Now, remember, if we look up here, that glucose, the molecule inside the equation or the product, has a coefficient of 1 on it. We're just not showing it because, you know, ones and all. Ones are shy. They don't like to be shown. When I'm calculating the grams of glucose, I'm going to use the amount of my limiting reagent. There's extra water. So that 15.9 grams of water given to us in the question is not going to get fully used. So I don't want to use that quantity because it will overestimate the amount of glucose I get. It's the carbon dioxide that is limiting the amount of glucose that I receive. So we're just going to set this up like a normal unit elimination question. In the next video, I'm going to show you a bit of a shortcut to basically just chop some steps out from here to here. But in this one, we're going to go back to basics and start from the beginning. So we want to figure out how many grams of glucose we have. So I'm just going to shorten that to gluc just because I don't feel like writing that whole thing out, or C6H12O6, that's a lot. Now, because carbon dioxide is the limiting reagent, we are going to use the grams of carbon dioxide as the start of our calculation because that's what's limiting. If we found that water was a limiting reagent, then we'd use the 15.9 grams given to us of water. But in this question, it's not, so we're going to use that. Now, we're going to convert that to moles using a mole of carbon dioxide per 44.0096 grams of carbon dioxide. Okay, that's going to eliminate grams of carbon dioxide with grams of carbon dioxide. Looks good. Now I've got moles of carbon dioxide, so now's a good opportunity to use the stoichiometric ratio of 1 mole of glucose per 6 moles of carbon dioxide. What that little red guy is on there. All right, that's going to cancel the moles of carbon dioxide out with the moles of carbon dioxide here. And just as a reminder where I got those from, that is the 1 and the 6 inside my equation. It's just way up there, so I figured I'd point that out. Now the last step is we want grams of glucose, so it's probably a good chance now to use the molar mass of glucose, which is quite large, 180.1566 grams of glucose per 1 mole of glucose. Again, those will cancel out. There we go. Leaving us with grams of glucose, which is, of course, the quantity that I wanted to begin with. So that's how you know that your question is done. And just a reminder where I got that from. Again, the molar mass of glucose right here, 180.1566. Okay. All right, great. Now, the last step, of course, is to do all the math stuff. So that's 6.26 divided by 44.0096 divided by 6 times 180.1566. There's a lot of 6's in here. I hope that's not a sign. I'm going to magically have the answer pop up right here. There it is. 4.27 grams of glucose is produced in this reaction. And that's the end of it. I know limiting reagents can take a little while. They're longer questions because essentially you have to do unit elimination a maximum of, well, I mean, however many reactants you have plus one. So, you know, 1, 2, 3 times in this question. I know limiting reagent questions can seem very daunting. There's a lot of steps involved, a lot of things you have to remember, comparisons. Think about it just as a 1, 2, 3 part unit elimination question, where the first 2 parts are you just trying to figure out which one's limiting, and the last part's doing the actual calculation. Anyways, if you have any questions about that, let me know, and we can go over it together. But there'll be another video coming, or there's another video posted with a second sample question. So check that out if you're looking for further explanation. Have a good one.